All right, so there's lots of other applications of line integrals. It's not just going to be work. And you'll see some of those in your homework. There'll be, I think there's at least one word problem, so that'll be fun. Interesting, at least. But one application I wanted to discuss was finding the mass and center of mass of a wire, because we've been talking a lot about density and mass and center of mass. So let's say you have this wire, and then maybe it's heavier in this chunk, and so like uneven thickness or made of different materials welded together, something like that. So then you can have a density function. So let's say this wire sits in the xy plane. You can have a density function of the wire based on your position x comma y in the xy plane, and then you have this curve c, and then your mass is just going to be the integral over c of density function x comma y ds. And then you use the ds formula from several videos ago. And that'll work in 2 or 3 dimensions, that's fine. And then if they ask for the center mass, you want to calculate x bar, y bar, and maybe z bar. We'll just do x bar and y bar for now. So that's going to be similar to all the other center mass calculations we've done. We just multiply by an x, still integrate. So integrate x times the density, ds, and then divide by the mass. So that's some sort of moment. And then same thing, y bar is integral y times the density, divide by the mass.